Hi guys, welcome to this video. This is Dr.M.MOORTHI, working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So in this video, we are going to discuss about the air-fuel ratio and the impact in SIA in the emission factors. So this is the lecture series of automotive engines and emission control, where this is the we have the series of videos where we are going where we have discussed about what is the air-fuel ratio and then a stoichiometric ratio, and then what is lean and rich air fuel ratio, and then how these lean and rich air fuel ratio will contributes the emission factor. And then with the air fuel ratio, it is a critical factor in internal combustion engine, directly influencing the engine's performance, fuel efficiency and the emissions. So the air fuel ratio is the mass ratio of air to the fuel present during the combustion process in an engine. So and then typically expressed in the rates such as 14.7 is to 1, where 14.7 is the part of air and the mix mean the mixture, and the 1 is the part of fuel by mass. So this is the air stoichiometric ratio where we are maintaining. And then with the stoichiometric ratio for gasoline engine, the stoichiometric ratio air fuel stoichiometric air fuel ratio is 14.7 is to 1, which is the ideal ratio where all the fuel is completely burned with the available oxygen, so resulting in the most effective and efficient combustion. And then the how the air fuel ratio will going to affect the emission. So the air fuel ratio has the significant impact on the type and then amount of emissions produced by an engine. So with air fuel ratio, with the type of lean and rich air fuel mixture, it's going to have a significant impact on engine performance and then emission factor. With the first one, we are going to we have the carbon monoxide. So the carbon monoxide is a toxic gas produced when there is an incomplete combustion of fuel. So this is usually occurs in rich mixtures where there is not enough oxygen to fully oxidize the carbon in the fuel into carbon dioxide. So with the air fuel ratio, the quantity of air have the significant role in the combustion process to make the complete combustion. So with a more oxygen to be presented in the combustion chamber, means we get complete combustion. With carbon monoxide will get the additional oxygen to formed as the carbon dioxide. So with the rich mixture, that is the air fuel ratio is lesser than the 14.7 is to 1, the higher level of carbon monoxide are produced because of insufficient oxygen. So with the rich air fuel ratio, we get the higher quantity of fuel. With the simultaneously we get the air, the quantity of air, it is lesser than 14.7. So with the higher the quantity of fuel present in the air fuel ratio or the in the combustion chamber, means there is insufficient oxygen, it leads to carbon monoxide emission. So with the lean mixture, it is greater than 14.7 is to 1. So it supplies the excessive oxygen to the in the combustion process, so that the fuel is completely burned, and then it produce the higher it produce the more energy when compared to rich air fuel mixture, so that the carbon monoxide emission are reduced. Yes, more oxygen is available to convert carbon monoxide emission into carbon dioxide. And then the next one is hydrocarbon. The hydrocarbon are unburned or partially burned fuel molecules. With the air fuel ratio is applied to the combustion chamber, we have the quantity of air, that is the oxygen, and then quantity of fuel in the combustion chamber. So this fuel is when is feed into the combustion process, and then the part of fuel is unburned or not burned completely, so that it produces the hydrocarbon emission. So the hydrocarbon emission occurs when the fuel does not fully combust, which can happen under various conditions, including cold starts, improper air fuel mixing, and then during rich operations. And the rich mixture means we get the more quantity of fuel compared to the air, means there is an insufficient oxygen available in the combustion chamber. So with that incomplete combustion of combustion of fuel leads to higher emission of hydrocarbon, and then the part of fuel is not complete burned, and then it leads to unburned hydrocarbon emission. And then with a lean mixture we are getting the higher quantity of air, and then with simultaneously less part of fuel is present in the air fuel ratio. It means during combustion process the lean air fuel mixture, it supplies more oxygen, or required oxygen to the fuel, so that it makes the complete combustion of fuel, and then it leads to hydrocarbon emission can be lower. But very lean mixtures may also result in incomplete combustion due to the poor flame propagation. So these are the factor of the lean and rich mixtures with the hydrocarbon emission, and then unburned and then carbon monoxide emission. Thank you.